In this video, we're going to be looking at section 6.4, and we have been working with vectors over the last few days. Today, we are going to look at what's called the dot product and some properties using the dot product. All right, when we are dealing with vector operations, there are times when the operations that we do give us the result of another vector, and these operations are vector addition. So you can see here if I've got vector 1, 2, and I'm adding vector -3, 4 to it, all you need to do is just add the components together, and the result of it is another vector. We also have vector multiplication by a scalar. Multiplying a vector, let's say 4, 5 by 3, you just multiply the 3 times 4 and then 3 times the 5, and the result is another vector. The one time when the result is not a vector in our operations is when we are doing a dot product. Now, a dot product, what it is, it's the multiplication of two vectors. So it's like vector v dot product, vector u. That's the symbols that you're going to see for that. Now, when you do the dot product, you actually get the result is a number or an integer. And so here's what we're going to do is we'll look at the formula. For the definition of a dot product, the dot product of vector u and vector v, where u is defined by u1, u2, and vector v is defined by v1, v2. The dot product is, here again is the symbols of it. You take your u1 and multiply it by your v1. So it's u1, v1, their product, and then you're going to add u2 times v2. And then this is going to give us a result, which is going to be a number. Let's do this example for our dot product. So we've got -3 times 1. So we're matching the corresponding parts to our vectors. And then we're going to add to that 2 times 4. So my result is -3 plus 8, which is 5. So the answer to the dot product is 5. And that's how the dot product is used. We also have some properties of the dot product. So if we let u, v, and w be vectors in the plane or in space, and let c is a scalar, so c is just like a constant. Some properties that we have is if you take the dot product of u times v, it is the same as the dot product of v times u. If you take in a dot product and you multiply a 0 vector by another vector, then you're going to get the result as 0. If you have the dot product which will look similar to the distributive property, then you would have the dot product of u and v plus the dot product of u and w. If you have the dot product of a vector and itself, what it actually is equal to is it is equal to the magnitude of the vector squared. And finally here, the last property is if you are multiplying the dot product of two vectors by some constant, it is just equal to c times the dot product of u, v. So you just multiply c times one of those vectors. All right, let's now use some of these properties. I have finding the dot product of these two vectors. So we would take 4 times 2 plus 5 times 3 equals 8 plus 15, which is 23. Again, you can see that when I do my dot product, you want to match up corresponding parts. You multiply to get 8, multiply to get 15, and then add the results together. All right, here are some operations to practice some of the properties. Here are the vectors u, v, and w, and so this is asking us to find u times v, the dot product of u and v, and then times w. You would want to look at your order of operations first. So we're going to go ahead and do the dot product here of u and v, and then we will worry about w in a second. All right, the dot product of u times v. So we would have negative 1 times 2 plus 3 times negative 4. So we are looking at a number. It's negative 2 plus negative 12. So it's negative 14. This is just a scalar now. A scalar times the vector w, which is 1, negative 2. So the result of this is going to be another vector. It's negative 14 and 28. So my goal here was to go ahead and do the dot product first, and that's because of the parentheses. You get a constant here, and then it's the constant times another vector, which is going to give us a result of a vector. All right, in this case right here, we are going to want to make sure that we multiply vector v times that 2. So we're going to have vector u here with the dot product. So u would be negative 1, 3. Dot product of, I'm going to go ahead and double vector v, which is 4, negative 8. This is a dot product now, so my result is going to be an actual number. So we would take negative 1 times 4 and add to it 3 times negative 8. Answer is negative 4 plus negative 24, which equals a negative 28. And there you have it. All right, we've got example 3 here, dot product and magnitude, like how are they related? This says the dot product of u with itself, so u dot product with u is equal to 5. What is the magnitude? Well, here's what we do know. We know that when you take the dot product of u times itself, it equals the magnitude of u squared. So if this is equal to 5, then the actual magnitude would equal the square root of 5. All right, the last thing that we're going to look at today is how to use dot product to help us find the angle between two vectors. If I have two vectors here, let's say vector a to b and vector a to c, and I want to find the angle between it here, calling it theta, or angle A. This is a formula that you have. We can do or find angle A by setting cosine of the angle equal to the dot product of the two side vectors, dot product of each vector, divided by the magnitude of each vector. You're going to want to write this formula down on your formula sheet, and then now what we will do is we will practice. Use the vectors to find the interior angles of a triangle with the given vertices. All right, here's my triangle. I've got negative 3, 0. I've got 2, 2. And I've got 0, 6. So we need to find the vectors for each of these sides of my triangle. We need to find the vectors. Let's go ahead and label our triangle A and B here and C. So let's go ahead and look at vector A to B. What would its component form be? So my component form would be 5, I'm subtracting my x's, and 2. Let's look at the vector from A to C. In component form from A to C would be negative 3, and 6. And finally from vector C to B. Vector C to B, or if we maybe go into a different order. Let's go from vector B to C. So from vector B to vector C, this was A here, this was B, and this was C. So I'm subtracting, and that would be -2 and then 4. All right. What we want to do is let's go ahead and find, let's find angle A first. So we do cosine of angle A equals the dot product of the two vectors that are on that form that angle. So it's the dot product of 5, 2 and the dot product of, I'm noticing here that this is this vector from A to C would have been 0 minus -3, so this should be a +3. That's a +3. And then from 3, 6 is the second vector, and then we're going to multiply those together, use their dot product, and then divide by each of their amplitudes. So the amplitude of AC would be the square root of 25 and 4, so that's the square root of 29. And the amplitude of 3, 6 would be 9 plus 36, which is 45. All right, this gives us dot product on top. It'd be 15 plus 12, so it's 27, over the square root of 1305. And what we're looking at here is we're looking at cosine of the angle. So cosine of the angle would be inverse cosine of the 27 over the square root of 1305. And what this gives us is 41.6 degrees. 41.6. All right, so that's angle A. And we are to find all interior angles. So let's go ahead and find cosine. Let's find B. Cosine of B would equal, so now we're looking at the vectors that are contained at the vertex of B. So we got the dot product of 5, 2, along with the dot product of -2, 4, divided by amplitude of square root of 25 plus 4 is 29, and the square root of 4 plus 16 is 20. Okay, so what we're looking at is we're looking at cosine of B equals, the dot product would be -10 plus 8 All right, now before we go any further with this cosine of B, what is important is that if I'm finding this vector, if I'm finding the vector from, since I'm finding angle B here, I need to go vector from B to C. If I go from B to C, well then what happens is this is a displacement of -5 and a -2. So we need to actually use -5 and -2 for this specific vector. What you might not want to do is list all the vectors like I did here, AB, AC, and BC, until you're actually finding your angle, because you need to make sure the vertex is the beginning of your vector. All right, and what we're going to have here is we're going to have then the vector, or the result on top of my dot product is going to be 10 plus -8, which is 2, divided by the square root of, and 29, 29 times 20 is 580. And if you do inverse cosine, then this would give us 85.2 degrees. So this is angle B, this is angle A, and of course we can find angle C by subtracting them from 180, which is 53.2 degrees. All right, that is it for this section. There's your assignment.